So stroke 1100, of course. This is sheet 5. Questions 11. So 11, we are given that the range of the functions, given the range of functions, sine inverse, cos inverse, tan inverse, negative pi over 2 to positive pi over 2. That is for sine, 0 to pi for cos inverse, and negative pi over 2 to pi over 2 for tan inverse, not included, of course. Evaluate a sine inverse of root 3 over 2. Now, you know that if we let x to be sine inverse of root 3 over 2, this is the same thing as sine x is equal to root 3 over 2. What do you sine inverse that guy is where you use a calculator, but if you are solving in a normal way, you write it as sine x is equal to root 2 over 3. And we know that the angle x that gives us root 3 over 2 operated via sine is x is equal to 60. And because the intervals are in radians, so we wish to write it in radians. So say x is equal to pi over 3. Now this is for sine, and the interval given is negative pi over 2 all the way up to pi over 2. So we pick another value of x where sine is likely to be positive in that interval. So if you go on the quadrants, you are talking of this distance here from 0 to 90, and this distance here in the negative direction. So you see that you cannot obtain any x here that will give us a positive value of sine. So we only get 1 in the first quadrant. So the only value that we have here is this one for sine inverse. Then B, tan inverse of root 3 are negative. So if it's negative, then we know tan is negative in the second and fourth quadrant. Okay. And in the second quadrant, here again, you let x be is equal to tan inverse of this negative root 3, which actually becomes tan x is equal to negative root 3. So what's happening? First, we know that x is equal to 60, again here, in the first quadrant, where tan is positive. So we need 2 values of x. Remember, tan is using this interval here. So if you go in the third quadrant, in the second quadrant, you won't find any angle that is between 90 and negative 90. The angles that are in here are above 90. So we'll come to the fourth quadrant and look for an angle that is 60 related in the fourth quadrant. So that angle is going to be, say, theta is going to be 360 Now let me just use the radians. 2 pi minus 60, which is pi over 3. So we know you're talking of 300 here. This is 6 pi minus pi over 3, which is 5 pi over 3. So this is the solution that we are looking for, the x. So the idea of tan inverse is, the tan inverse is done on the calculator, but in the actual solving, you write it as tan x is equal to the value that is inside the inverse. On the calculator, you do the second function for you to find that x there inside. But now it's given, then what angle? Okay. So really here there is nothing. It's just all about that. So where we enjoy is on question 12, where the inverses are inside some normal functions. So let's see what happens there. Question 12. We have the same intervals. Yeah. Like in the previous question. No, here we're just dealing with 2. So given that sine inverse and cos inverse are ranging in negative pi over 2 to pi over 2. This is the range. And 0 to pi respectively. So meaning sine inverse is negative pi to pi over 2. Cos inverse is from 0 to pi. Then evaluate A sine cos inverse of half. So what do? You go inside here and let the inside be x. Let x be cos inverse of half. Then you'll be like solving something like cos x is equal to half. Now cos is found in this interval. So x is what? For cos that gives half, x is 60. So x is pi over 3. That's why we get half. And we can't get any between 0 and pi that gives us a positive cos. There. No, the inside is cos. So the inside is cos. And then we pick this. We pick the inside. So now we are saying the inside is equal to pi over 3. So what we have now here is sine pi over 3. And this is sine 60. So sine 60 is root 3 over 2. This is us, because we said this whole thing here is equal to x. And we have found x to be root 3, to be pi over 3. So that is what we get there. Okay, another one so that you can see properly. Cos.
So where is pi over 3 coming from?
So like pi over 3 is 60, right? And cos 60 is what gives us half. So we're getting it from here.
Okay, thank
you. Yes. Okay, now we have this one, cos and then sine inverse of half. Cos then sine inverse of half. This is like this is sine inverse of half. Then we'll have like sine x is half. So what is x? X is 30, which is pi over 6. Then when x is 30, it means inside here we have 30 because we have said this guy is x and we have found x to be this. So this is going to be cos x, which is cos pi over 6. And what is cos pi over 6? Cos pi over 6 is cos 30 is root 3 over 2. Is there anything difficult? Here we only had 2. Okay, maybe you look at question 13. Like, prove each of the following. A, you have sine, and then inside there's cos inverse. That's given as x over 5. Prove that this whole thing is equal to the root of 25 minus x squared over 5. So the root of 25 minus x squared over 5. We want to prove. So what we'll do is we'll ignore the left-hand side. Let's get the left-hand side and say, oh, this is sine cos inverse of x over 5. Like that. Then we'll say, okay, in here, if we let x, so now we let p, let's say theta is equal to cos inverse of x over 5. This is the same thing as cos theta is x over 5. Like that. Then now what is a theta? Well, we know that from SOHCAHTOA, the relationship of this one is very simple. If we have got a triangle like this one, and we place theta here, and this is 90, then we have cos theta is equal to adjacent over hypotenuse. So it means the other side is going to be hypotenuse squared minus adjacent squared. So this whole thing inside here has been named theta. This theta that is here. So we are now saying sine theta is equal to, what is sine theta here? Sine is opposite, which is root 25 minus x squared over hypotenuse, which is 5. But what is theta? Theta is cos inverse of x over 5. So this is equal to 25 minus x squared over 5. Very nice. So your task is to do the task is here to do 13B. So question 13 is, its concept is on the triangle. When you let the inside to be a special angle, to be an angle, then you redo the inverse, you get to the normal cos. And then whatever remains here, because x is unknown, you take it on the triangle. these acts like the sides of a triangle. If it's cos, you know it's adjacent of hypotenuse. If it's sine, it's opposite of a hypotenuse. Then you find the missing side. If it's tan, opposite of adjacent, then find the missing side. And then you would find, if this outside one is sine, then you find sine of the angle that you have chosen. Whatever you get, you substitute back your chosen thing, then you'll be done. So I'll give you 13B and see what you get. So on Wednesday, we'll still be looking at trigonometry. No. We'll move a bit to go to exponentials. Yeah, on Wednesday, we'll introduce exponentials and logarithms. And then when they announce the quiz is around the corner because 1100 they're writing next week. So it means that the other week we expect either 1100. I mean, 1110 they're writing next week on Monday. So these other two courses we expect either after next week, there will be 1100 or 1120 or both. So if you are thinking there's due time, you start later studying, this is the time to start. You have a lot. There's polynomial. We haven't been tested on polynomial. And the whole trig. And now the lectures on exponential and logs. So here, this one we're starting on Wednesday. And we see how it goes. This is a very short topic. But all these. So let's be serious at individual level, so that you don't start panicking when they say there's a test. Okay, so we end here. Answer 13B. Answer 13B. Let me teach my engineering students.